మీ రోల్ నెంబర్స్ ఇచ్చారా మరి? ఓకే. Okay, let's part example problem. So this is the given grammar. So already I given this grammar. So for this grammar, I have to construct LR of 0 parser table. So before constructing this parser table, first we construct DFA, that is data flow diagram. That is, first you can consider augmented grammar by adding this new production S dash tends to S. So first write augmented grammar. With new starting symbol S dash, and by adding this new production, that is S dash tends to S, and S derives AA, and A derives AA B. And then first write the augmented grammar, means by adding this new production, and then you can find closure function of the first production. That is the first production. So closure of S dash derives S, you have to find first. So closure of S dash tends to S is nothing but you can write the LR of 0 item by dot over that symbols at right side, means you can write like this. S dash derives dot S. After dot, if there is a non-terminal, you must include that non-terminal productions also. It is nothing but closure function. It is nothing but closure function. So dot S is nothing but add all S productions. All S production with dot over the symbol, beginning with dot. Can add all productions, S production, beginning with dot. So I have to write S derives dot AA. After again here, after dot a non-terminal is there, so can also include that A production with dot beginning, dot with B. So A derives dot AA, and one more production is dot. So this is nothing but closure of S dash tends to S. This is considered as one step. This is considered as one step. On this state, you can do some transitions. So what transitions you can consider? After dot, this symbol is there, you can do transition on that one. That is nothing but, that transition is nothing but go to function. Go to on this production, first production. On this first production, I will do the transition on S. Why? Because dot is here, and you can do transition on S is nothing but dot will be coming after that S. So here the transition will be on S, after dot S is there, so can do transition on S. On A, for this production, after dot A is there, can write transition on A. And after dot, a small a is there, terminal. You can also do transition on terminals and non-terminals. Here after dot, B is there. You can do transition on B. This is nothing but S derives go to S derives AA on A, and what is that? The production is go to A derives AA on A, and A derives B on B. Okay, can do the transition and write the closure. So whatever the productions will come after dot, if there is a non-terminal, so include all that non-terminal productions. That is nothing but you have to find closure. So first moving dot and the first value. So can write it as S dash So a transition on yes is nothing but moving this dot from here to here. So you can write it as like just you can do transition on yes. Just check after dot yes is there. A productions at after dot yes undo, so you can write those productions here. Just moving the dot from here to here. From here to here. So after that, if there is a non-terminal, you can also include that non-terminal. But after that, there is no non-terminal. So only one production in the state. So consider this is I0 state and this is I1 state. Okay, next do like that. You can also transition on A next. So on this production, you are applying A is nothing but you can get is there A dot E. Just moving this dot from here to here. A dot A. Okay. Dot tarvata malli is getting a non-terminal. So add all non-terminal production. But our non-terminals can start what is the dot at beginning. So for that production, dot at the beginning long. Dot AA dot. Okay. After that again check it is there any non-terminals. But here after that only terminals are there, no need to include anything. So this is the next step. So transition cheyali and at the same time we can also perform closure operation. Closure operation is nothing but after that if there is a non-terminal, include that non-terminal production. Where is this one? So you are moving dot, we are transition on A, right? So for this production, you are performing transition on A. So that moving dot from here to here. So A dot A. So moving the dot from here to here. So after that, there is a non-terminal A. So you include that now. Compulsory if there is A after dot. So you can include those productions also. Okay. Again, it add that production and you can write dot at beginning. Compulsory can add the dot there. And next again you can perform transition on this one, on small a. So we are moving dot from here to here. So what happens? A derives A dot A. So this dot is moving from here to here. So we are getting A dot A. Okay. After dot again A is there. So again you can add the A production. A derives A B. So dot at beginning. So compulsory can write dot at beginning. Okay, this is one more production. This is one more state with this production. And next, what is the transition to do for this one is on B. On B. That is A derives dot B is there. So you can write it as A derives B dot. This is one more production. So after B, after dot there is no non-terminal, no need to add anything. Okay, so you are getting the complete item. This is nothing but complete item. Why? Because dot at last. Dot at after all the symbols. This is nothing but final item or final item under. This is the final item. Okay, and this is I1. Just give names to these states. I1, I2, I3, I4. Again, if there is any possible to do the transitions, you can do it. So on this, దీని మీద ఏ ట్రాన్సిషన్ చేయడానికి లేదు ఆఫ్ డాట్ at last. So whenever you reach this state means the string is accepted. Why you had added this augmented grammar? You can say whenever you can get yes means it is accepted. So whenever you can reach this particular state means the given string is accepted. Okay, it is a final state. Final state. You can also consider as a final state. And why? Because it contains a final item with augmented grammar final item. It contains augmented grammar final item. So whenever a augmented production is there with a final item, you can say that the given input string is accepted. Okay, I will show in the table. Okay, next just sequence the student. So I1 with the need not to apply anything. Next apply on I2. Is there any possible to do any transition on I2? Dot tarvata check it. Dot A మీద చేయొచ్చు and small a మీద చేయొచ్చు again on small b మీద చేయొచ్చు. So it's possible. 3 transition is possible on this stage. 3 is possible. Okay. So on capital A. So on capital A చేసినప్పుడు what is the transition? What is the production you get? AA this dot will move from here to here. Okay, so we are getting this production. After that there is no symbol, so this is the only production in the state. Okay, next do transition on small a. So next a derives mostly a dot a. So we are moving the dot from here to here, right? A dot a, and again a is there. So again write the productions, a productions with dot over at beginning, a dot b. So this state is already exist, right? This state is already exist here. That is a derives a and a derives dot a dot b. So same productions are there in this state, and directly on a it gives to this state. No need to new state. It already existing state occurs, so it gives directly to that state. On the symbol on a it goes to this state. Okay. Next do transition on b. It gets a derives b dot, right? A derives b dot. So that is also already exists. So on b goes to this. Sequentially you can check the transitions. What transition is possible? Just apply the transition on that particular state. Okay. So next this state is completed. All transitions done on this state. And next do transition on this state. What transition is possible for this state? On capital A, on small a, and small b, right? Okay. Small a means self personally. So capital A means we are moving the dot from here to here. So it is a new state, right? After that there is no symbol, so it is a complete state or complete production or final item. Okay. And next on a mostly a derives a dot. So on this production you are performing transition on a, means you can get a derives, this dot is moving from here to here. We are getting this, sorry, a dot a. Okay. After dot a is there, you can include a production again. So that is nothing but you are getting the same state. Means on a it gives to the self loop. On a it goes to self. You are getting the same step. On a you are getting the same production. So self loop is just you are giving self loop on a. Next on b, it goes to again a derives b dot of c. So moving this dot from here to here means you are getting the production a derives b dot. B dot means you are giving again on b it goes to this state. Okay, what are the possible transitions on this I3 state? On capital A, small b, and capital A are getting the new state. On small a are getting the same state, so are giving the self loop. On b are getting this state, means are giving like this. So next I3 is completed. Next coming to I4. I4 is already the final item. No transitions is possible on this state. This is I4. Next this is I5. So it is also a final item. No need to do any transition on this state. Next this is I6. So it is also a complete item and a final item. No need to do any transition on this state. This is the DFA. This is a given DFA for the given grammar. So from this table, from this diagram, we have to draw parser table. That is, a parser table is very important. So parser table, I will draw the starter first. Here you consider action. Go to. I already told that parser table contain action and go to. LR parser table contain action and go to. Okay, row wise write all the states. So how many states are there? I0 up to I6, right? So you can just write numbers 0, 1, 2, 3, 4, 5, 6. So this is nothing but states from I0 state to I6 state. Okay, and in action table, action column, write only terminals. What are the terminals here used? A, B. So write that one. A, B and dollar. Can also include dollar. A, B, dollar. Okay. And in go to in go to column, you have to write only non-terminals. What are the non-terminals are here? Yes, sir. Yeah, no need to write S dash. You write only the non-terminals S and D within that program. Yes. Yes. S dash only for accepting purpose only. No need to write that production. So whenever you reach this I1, you can say that that is accepted. That's all. So that is not shown in the table. Okay. So write only the production. Non-terminal S and D. Okay. And can also give production numbers here. This is the first production. We are not considered just adding. So the augmented production add chedu. So the first production is S derives 1 1. Second production and this one A derives AA is the second production. A derives B is the third production. We are giving the name. And our production to we are reducing. You can reduce this one by this one. So you can give the numbering. So this is the first production. This is the second production. And A derives B the third production. Few numbers today. Last for later. Three productions. Okay. So దీన్ని ఎలా ఫిల్ చేయాలంటే సో యాక్షన్ లో హ్యాడ్ రైట్ టర్మినల్, గో టు లో రైట్ నాన్ టర్మినల్, okay. So based on the transitions, just listen carefully. This is 0 is nothing but I naught. So on this state, what are the transitions will done? That will be you can write here shift action. So whenever you can do transition on non-terminal, if you are doing transition on non-terminal, so I naught on yes, it goes to the state I1, right? It goes to the state I1. So you can write on 0, I0. This is nothing but I0. On yes, it goes to the state I1 means you can write here 1. Only write numbers. Whenever you are doing transition on non-terminals means you can just write numbers. Ikkada only numbers uttayi. And ikkada action is nothing but you can perform shift and reduce action. You can write shift and reduce action here. Terminals lo shift reduce actions rayali. Non-terminals lo only you have to write the state change. And applying is we are changing the state to 1. 0 is changed to 1 like that. Okay. And next it is also non-terminal, right? So it goes to the state 1 and it goes to the state 2. So 0 on A it goes to the state 1 2. On yes it goes to the state 1. On 0 on A, I naught on A it goes to the state 2. So just write the numbers. Whenever it is a non-terminal, just write the numbers. That number is nothing but you are just changing the state. That's all. You are just changing the state. Okay. Next, whenever you can see the non-terminal, whenever you can perform the transition on terminal, I naught on A, it goes to the state I3. Okay, I3. It goes to the state I3. So, here you can perform shift action. Whenever a terminal is there, terminal means transition chestunante, you can perform shift action. So, it is also terminal, you can perform shift action. So, you can write 0 on A, shift action. 0 on B, shift action. Okay, A and B మీద shift action చేస్తున్నాం. We are performing shift action and you are changing the state to on A, changing the state to 3. So you can write here yes. And again here on B, you can perform shift operation and also change the state from 0 to 4. So here write yes. S3, S4. So that is like that you can fill the table. Okay, and final item ఉన్నప్పుడు different గా చేస్తాం. Final item ఉన్నప్పుడు you can perform reduction action, and whenever there is a transaction you can do shift action. Okay. So next I1. Next coming to here. So there is no transitions on the state, right? And it is a augmented final item. Augmented gamma final item. So augmented final item ఉన్నప్పుడు $1 and $1 right access. 1 and $. So 1 is nothing but I1 state. In I1 state, augmented production complete item is there. whenever augmented production complete item is there, means the given string is accepted. So you can write a entry on $1 and $. On $1 and $, write accept. That's all. Inkem undadu. Okay. Next, coming to I2. Next, second state, capital A undi, means non-terminal meeda undi kabatti it goes to the state 5. So 2 on A, state number 5. 2 on A, state number, right? Just it changes the state, that is to 5. And next, small a, small b, these are good transitions unnai kada, is nothing but shift actions on to, you can do transition on A and B, okay, small a and small b. So can small terminals is nothing but shift action వచ్చేస్తుంది, right? Shift action and change the state. 2 నుంచి A state ki change అయింది. On A it applying the, it goes to I3 state. So we write S3 yes, S3 yes. Shift action చేస్తాం. Whenever you can see the terminal, shift action చేస్తాం. At the same time we are changing the state. Should write the state number here. S3 S4. Completed, right? On second state, all transitions are completed. Next, fill S3, I3 on capital A is there, right? On capital A, it goes to the state 6. And next, small a, small b, terminals with on the shift action, right? Shift action, and it goes to the state, same state, S3 and this. Next, I4. And whenever, so then A transitions leave. I4 is the state and there is no transition on I4 and it contains complete item. It is a complete item. The production is complete item. Whenever a state contains complete item, you can perform reduction operation in complete row. Okay. So, and which production it is? Which is production number? What is the production number of that one? A derives B, third production. That is the third production. So in all this, in that row, you can perform reduce action. Reduce with production? Third production. So you can mention that number here, R3. A number endante, so our production to manam reduce cheyali. Just it is a number indicate. And you can reduce using this production. So in complete row, other than this non-terminal, terminals low, you can write the reduction. Next, I5 is also, there is no transition and it contains a complete item, final item, and if it is a final item means you can perform reduction. So write reduction first and reduction with production number. Reduction with this production, first production. So write R. Yeah, complete or final are same. So whenever dot at last means it is a final or complete item. Only for augmented grammar. It is also a final item or complete item, but it is a augmented grammar. Whenever a augmented complete item or final item is there in a state, that is nothing but accepted. Only for that one. So it is a augmented grammar. It is you are adding a new production, right? Production final item A state like vastundo. Okay, that is nothing but that whenever you reach that one is nothing but you can accept the string. So you can write $1 and $. Accept. Next, I6. See the I6 state. It is also a complete item and there is no transition on this one. So it is a complete item. Can perform reduction operation. Reduction and reduction with which production? Second production. So write R. That's all. This is a parser table. By using this parser table, you can parse any string for this grammar. Okay, is it clear? Is it okay? Shift where you perform shift action, where you perform reduce action. Okay, and after S, these are all state number, and after R, that is nothing but production number. Don't confuse, these are all production numbers 3, 1, 2, only 3 productions కాబట్టి 3, 1, 2, 1, 2, 3 మాత్రమే ఉంటాయి. And shift లో that is nothing but state numbers. After shift, state numbers. Okay. We'll erase this diagram. Okay, next you can pass a string using this table.
Instead of the last part of
So this is a given string, AABB is the string. So, and check whether this string is syntactically correct or try to check it. And whenever you can get this empty slot, empty entry means that is nothing but error. But all empty strings, empty are error. Whenever you can get that entry means the given input string is syntactically wrong. Okay, it contains some error. So initially stack contains dollar and initial state. This is nothing but state. 0 is state, I not state. Okay, initial state. Okay, so stack contains dollar followed by initial state, and input content. This is we're passing input string is AABB with this grammar, with this parser table. Okay, so e grammar ki manam construct chestundi. This is nothing but LR of 0 parser table. So in LR of 0 parser table, whenever a final item is there, you can perform reduction in the complete row. Anni terminals, any terminals unte anni terminals lo reduction pettastam. That is nothing but LR of 0 item. LR of 0 parser means without seeing any locate symbols. 0 means here without seeing any locate symbols. Whenever you can get a terminal means you can perform some reduction. That is the purpose of this name LR of 0. Okay. So this is the given input, and initially stack contains this one. So already know that shift and reduce action. Bottom up parser is nothing but you can perform shift and reduce action. Okay, either shift the data into the stack, and whenever you can get a handle onto the top of the stack, you can perform reduction. Okay, and this shift and reduce action is performed by using this parser table. Okay, so first thing is see this symbol. Initially 0 is the initial state. The first symbol 0 on A. What is 0 on A? We are performing shift operation. So can shift the data from input to stack. So $0 A. A states alage untayi. And it changes the state to 3. Okay, shift chestam. At the same time you can change the state 0 to 3. So adi kuda push cheyali. It is changes to 3. So we are shifting A, and the same time 0 on A, it goes to the state 3. State number kuda raali. Next 3 on A. 3 on A, what will you do? Shift action, and it changes the state to 3 name. It is in the third state. So you can also write that A3. Okay. Next 3 on B. Shift again. Shift the input symbol. Shift this input symbol B here, and change the state to 4. B4. Yeah, we have to write 0 on A, S3, shift S3. We are performing S3 here, also S3 and here S4 అలా రాసేస్తాం. Okay, B4 and 4 on B. 4 on B. Reduce with which production? A derives B production. Reduce action, you are performing reduce action with production A derives B. So on top of this tag B handle occurs. In place of B you write A. In place of B, so in place of B, reverse lo chestunna manam. In place of B you return A. So you can reduce with this production. Okay, B place lo had to write A. So what is changes? 0, A, 3, A, 3. So B4 place lo A vachestunది. B4 place lo A vachestunది. Again A change ayi and what is the state? 3 on A. So can see like this. 3 on A. 3 on A, capital A. Intena 6. It goes to the state 6. Compulsory state kuda check chesukovali. Only reduce action kaadu. You can also perform change the state. Okay. Ikkada emaindi? B will be reduced, right? In place of B, A rasesam. And again apply 3 on A. So mundarunna state paina again I can apply that non-terminal 3 on A. It goes to the state 6. So can push the 6 here. 3 on A. 3 on A goes to the state 6. 3 on A goes to the state 6. You can write that 6 out. Okay. And B dot. And next 6 on B. 6 on B. Reduction. Can perform reduction with which production? Second production, that is reduce A derives A. Reduce with this production. And just check it AA is occur or not. So here AA is there in the top of the stack. AA is there in the top of the stack. AA. Okay, so this is modified by, that is reduced to capital A. So you can write 0 A 3 A capital A. So ఈ మొత్తం ఈ 4 characters place లో A రాస్తాం. That is reduced. AA is reduced up to A. AA. So మన టాప్ లో ఆ పర్టికులర్ ప్రొడక్షన్ సింబల్స్ ఏవైతే ఉంటాయో అక్కడ నుంచి అటు రైట్ instead of the 4 characters you write A. Okay, again 3 on A, 6. 3 on A, 6. Again 6 on B. 6 on B. A derives A. ఏదైనా మిస్ అయిందా ఇక్కడ? Six on B, reduction operation A derives AA. So up to here, right? AA. So these 4 symbols is reduced to, then just strike off like this. And this is reduced to capital A. Reduced to capital A. So 0 on A again, 0 on A goes to the state 2. So compulsory after each non-terminal or terminal state number ఉంటుంది. Just check చేసుకోండి. Every terminals or non-terminal in between those a number is there. You can check that one. So sometimes ఏం చేస్తారంటే రెడ్యూస్ చేసి స్టేట్ నెంబర్ రాయరు ఇక్కడ. కంపల్సరీగా స్టేట్ నెంబర్ రాస్తేనే ఇట్ మినిమైజెస్. ఓకే, సో 0 on A. So 0 state on A, it goes to the state 2. So write that one. 2 on B. Next, 2 on B. 2 on B shift action means 0, A, 2 and shift the symbol to here and change the state to 4. S4 right? S4 means write B4. And ఇక్కడ ఏముంటుంది డాలర్, జస్ట్ డాలర్ and you are performing S4. Right? Next 4 on dollar. 4 on dollar. Reduce action with which production? Reduce action A derives B. A derives B. So B ekkudundi? So here it is B4 and in place of B4 write 0A to A. B is reduced to A. B is reduced to A. And again 2 on A. 2 on A, 2 capital A. 2 on capital A is 5. Write 5. Don't miss to write this state number. Compulsory you have to write it. After reduce to a particular symbol and again apply. So, before untundi kada state, on that state apply that non-terminal. 2 on A becomes 5. Okay, and here it is. The input symbol is dollar. Next 5 on dollar. 5 on dollar reduce with R1. Okay, reduce with first production, that is S derives AA. So AA is here, right? AA, so dollar 0 yes. AA is reduced to yes. And 0 on yes. 0 on yes. 1. 0 on yes. 1. Okay, next 1 on dollar. 1 on dollar access. That's so you can see 1 on dollar. So 1 on dollar means you can get access. Means the given input is syntactically right. Is it clear? Like that you can derive the string by using this parser thing. You can reduce the action, reduce with a particular production and shift the actions. And every time you can check in between any two terminals or non-terminals, there is a state number. Those are all state numbers. Okay. And note down one grammar and try to draw the parser table for that one. First add augmented production or augmented symbol here S dash derives S. This is the given grammar with 6 productions and we are adding one more new non-terminal here S dash. Okay. And directly draw the DFA diagram first and then you can draw the transient table. Okay. So first we consider dot over this first augmented production S dash derives dot S. And after dot S is there, so include all S productions with dot over dot beginning. So dot AA, right? Dot BAC, dot BC, dot BB. Okay. And after dot here for any S production, after dot capital A is there and ikkada capital B kuda undi kabatti you can add all A and B productions. A derives dot D, B derives dot D. This is one state, that is I naught state. Next, do transition on this state. A transition says to on S. Okay, after that A is also there. So A, capital B, small b, small d, right? And one more thing, first construct the diagram and then table, and if the table contain multiple entries, sometimes you can get multiple entries, shift reduce actions or reduce actions. Allow chain quantity, it's a conflict, it is a conflict, either you can reduce or shift on it. So whenever you can get like that, means it is not a LR of 0 path circuit, means it is not a LR of 0 grammar. Okay. So only these transitions are right. S, A, B, on B, on D. Okay. So first on S, same as me, S dash there, S dot. Completed. S dot, after that there is no symbol, so no need to write anything. So that is the final one item. This is I1. And next on A, S there, A dot A, right? This one, on this production I applied. So you can get A dot A, capital A dot A, and inka A to start dot A to, so only one production. And one more thing, after dot there is a terminal, so no need to add anything, so only you can get one production. Next on B, A derive, B dot C. That's all right. You can B to start so after dot there is no only this production, after dot B is there, so write A derives B dot C, and C is a non terminal here, C is a terminal, nothing is, yes ma? Yeah, B dot C. Oh sorry, yes side. Yes, S derives B dot. Okay. Next on B, S derives B dot AC, and this also start with after dot B is there, you can also include here S derives B dot B. So dot tarvata symbols evaithe start avutayi, you can write all that productions here. So here after dot small b is there, after dot here also small b is there. So write these two productions in one stage. S derives B dot AC, B derives B dot A. S derives B dot B. Okay. Again here A after A dot non-terminal is there. You can also add those non-terminal productions. A derives dot. And after dot B kuda undi kabatti B also can write B productions. A derives dot D, B derives dot D. This is one step. Next on D, do transition on D. So here A derives D dot, B derives D dot. So these two start with after dot D is there for these two productions. So I included these two productions here. So can get A derives D dot, B derives D dot. Okay, next, and this is the transition on first state, and give numbering here I1, I2, I3, I4, I5. And next, mali I1 nunchi start cheyandi. So I1 is the final item, no need to do any transition. And next, perform transition on this I2. What transition you can perform? On small a. On small a. After dot A is there, so can do transition small. Is there a dot? That's all. After that there is no symbol, so no need to add it. Next, for this one, on, see after dot C is there, so can do transient small c. So that become S there is B C dot. Okay, next on this one, so many transition will come. On A vastundi, on B vastundi, on D kuda vastundi. On D ante again it goes to this state, right? On D annappudu, so these two productions dot here after dot D is there, so can write A derives D dot, B derives D dot. So this is nothing but you are getting this state. So on D directly can give to this state. Next on A, that become S derives B A dot C. So C is a terminal. C is a terminal and it is a small c. C is a terminal, so no need to add anything. Next on B, BB dot A, that's all. A is a terminal, no need to add anything. On D it goes to this state. And on I4 it is contain actually final state, no transition will done on that. And next, this is I6, I7, I8, I9. Okay. Next, din mida it is a final item. No need to do any transitions. It is also final item. And din mida avutundi on C. Yes, there is BAC, small c, dot. And next, here on A, on this stage. Yes, there is BB, A, dot. Okay, and this is I9, I10, I11. So total 11 states are there. 11 states, and set last for I10, I11. So these also contain final items. No need to do any transition. So total 11 states are there. So you can draw the transition. What is that parser table first. So action go to the non-terminals are SAB and terminals are ABCD dollar. ABCD dollar. And give production numbers. This is the first production. 2, 3, 4, 5, 6. Total 6 productions. And next write first state. 9, 10, 11. Total 11 states. Next, and first state, okay, so zero state. So first apply, write non-terminals. So SAB are the non-terminals. So SAB apply chesinapudu it goes to the state 1, 2, 3, right? 1, 2, 3. On S apply chesi it goes to the state 1. On A 2. On B it goes to the state 3. 1, 2, 3. And next you are applying the terminals B and D. So B and D దగ్గర shift action వస్తుంది. B and D దగ్గర shift. Terminals వచ్చినప్పుడు transitions on terminals means you can perform shift action. Shift and B applies as it goes to state 4. So yes, 4 here right here. And this is on D it goes to state S. Okay, I not completed. Next I1. So here is the what is the final item. So the augmented final item is there in the I1 state. So $1 on dollar, write directly $1 on dollar accept. Mostly one I1 state lone vastundi augmented final item. You can write $1 on dollar accept. Next I2. On I2, which functions are perform I2 on small a. Small a shift action. And it goes to state 6. So write S6. Next on I3. This is I3 state. You are applying C and you can perform shift action 3 on C. 3 on C shift action and it goes to state sub. S sub. I3. Next I4. I4 were performed on non-terminals A and B. 4 on AB. 4 on AB goes to state 8 and 9. Right? 4 on A 8 on B 9. So if it is non-terminals, you can just write the state numbers. It goes to 8th state and it goes to 9th state. And on D shift action 4 on D shift action yes S5. Next I5. I5 contains final items, right? I5 contains final items, 2 final items. And the production numbers are 5 and 6. So here you can get, can reduce with R5 or also reduce with R6. So here you are getting reduce conflict. So actually 2 conflicts will occur in parser table, that is reduce conflict, that is RR conflict antam or SR conflict. So మనకి ఇక్కడ reduce conflict వచ్చింది. So why? Because here production 2 production final items ఉన్నాయి కాబట్టి you are getting the 2 reductions. So whenever you can get a state with 2 final items, definitely you can get a conflict with reduce conflict. You are getting a reduce conflict. This is also one problem in shift reduce parsing or any part LR parser. Shift reduce so ఎప్పుడు వస్తుందనే చెప్తున్నాను. Whenever a state contains 2 or more final items, definitely you can get reduce conflict. And ఏ production to reduce చేయాలి, either we reduce with this production or reduce with this production. అంటే D is replaced by A or this D is replaced by B. So that is nothing but reduce conflict. Actually this grammar is not LR of 0 grammar, means LR of 0 parser table. Why? Because we are getting this conflict. Okay, just the concept. Okay, next I6. I6 is also a final item. Okay, final item and the production number is R1. So you can reduce with production number 1 and write R. Okay, next 7. It is also final item and this production it is third production. Third production, so R3, right? R3 in action table. Action terminals lo emaitune annitlo reduction rasu. Next I8. It is not a complete item. We are performing some transitions here on C, and C is the terminal. Terminal means you can perform shift action. So 8 on C shift, it goes to the state 10 S10. Next I9 on A. So small a, it is a terminal, so perform shift action and it goes to state 11. I9 is completed. Next I10 ekkada I6, I7, I8, I9. Yeah, I10 contain complete item, right? And that production number is 2, R2. So we can reduce with production number 2. Next 11th state also contain a final item and that is the 4th production R4. So this is LR of 0 parser table, but this table contains two multiple entries. So we are getting a conflict, reduce conflict. Okay, but it is not a LR of 0 parser. This grammar is not a LR of 0 grammar. So in LR of 0, so మనకి డెఫినెట్ గా కాన్ఫ్లిక్ట్ వచ్చే ఛాన్స్ ఉంది. వై బికాజ్ మనం కంప్లీట్ రో లో రెడ్యూస్ రాసేస్తున్నాం. అక్కడ ఏదో ఒక షిఫ్ట్ యాక్షన్ ఉంది అనుకోండి, డెఫినెట్ గా ఒక గెట్ షిఫ్ట్ రెడ్యూస్ కాన్ఫ్లిక్ట్ వస్తుంది. అంటే మీన్స్ a state contain a complete item and also do some transitions. Okay, so number of ఉన్నాయి ఇక్కడ. ఒక కంప్లీట్ ఐటమ్ ఉంది. ఓకే, ఒక కంప్లీట్ ఐటమ్ ఉంది అండ్ అగైన్ we are performing some transitions, other production with transitions. సో ఇలా ఉందంటే కంపల్సరీగా షిఫ్ట్ యాక్షన్ వస్తుంది అండ్ ఇట్ ఇస్ కంటైన్ ఏ ఫైనల్ ఐటమ్ కాబట్టి రెడ్యూస్ యాక్షన్ కూడా వస్తుంది. సో at that time we are getting shift reduce action, shift reduce conflict lack. Okay, సో అలా వచ్చాయంటే మల్టిపుల్ ఎంగేజ్మెంట్ ఈజ్ నాట్ ఏ LR of 0 grammar. సో ఎలా వస్తుందంటే ఎందుకంటే అన్నిట్లో ఫిల్ చేసేస్తుంది. ఫిల్లింగ్ వెన్ ఎవర్ ఏ కంప్లీట్ ఐటమ్ ఇస్ దేర్, ఫైనల్ ఐటమ్ ఇస్ దేర్. సో కంప్లీట్ గా యాక్షన్ టేబుల్లో యాక్షన్ లో ఫిల్డ్ విత్ రిడక్షన్. ఓకే, దట్ ఈస్ ద ప్రాబ్లమ్ ఇన్ LR of 0 grammar, LR of 0 parser. If the grammar is very simple, you can get without any conflict, you can get the table. But grammar కొంచెం కాంప్లికేటెడ్ ఉన్నాయనుకోండి, కంపల్సరీగా there is a chance to get conflict. Okay, so to avoid this one, you can construct SLR of 0 table, SLR of 1 table, that is called simple LR of 1 table. Okay, so in SLR of 1 table, shift action are same. What are the shift actions ఇక్కడ మనకి LR of 0 లో చేస్తున్నామో సేమ్ యాక్షన్స్ విల్ డూ అండ్ రిడక్షన్ ఒకటి డిఫరెంట్. రిడక్షన్ యాక్షన్స్ ఎక్కడ పెట్టాలన్నది దట్ ఈస్ ఓన్లీ ద డిఫరెన్స్ బిట్వీన్ SLR అండ్ LR. సో SLR లో ఎక్కడ మనం రెడ్యూస్ యాక్షన్స్ పెడతాము అంటే ఫాలో ఆఫ్ దట్ సింబల్, whenever you can get a final item. For example, you are getting your final item, right? సో మనం ఇక్కడ ఫైనల్ ఐటమ్ వచ్చినప్పుడు ఏం చేస్తున్నాం, LR పార్సల్ లో దే ఆర్ స్టిల్ కంప్లీట్ రిడక్షన్ కంప్లీట్ రో, రైట్? బట్ అలా కంప్లీట్ రో లో ఫిల్ చేయకుండా, సో వెన్ ఎవర్ యూ కెన్ గెట్ ఎ ఫైనల్ ఐటమ్, ఫాలో ఆఫ్ ఎస్ సింబల్స్ ఏవైతే ఉంటాయో ఓన్లీ దోస్ సింబల్స్ లో మాత్రమే రిడక్షన్ పెట్టు. దట్ ఈస్ నథింగ్ బట్ SLR of 1. ఇట్స్ వెరీ సింపుల్. ఇఫ్ యూ నో LR of 0, యూ కెన్ ఈజీలీ కన్స్ట్రక్ట్ SLR of 1. సేమ్, ఎవ్రీథింగ్ ఇస్ సేమ్. Go to table is same, go to rows, columns are same, and ఈ యాక్షన్ కూడా షిఫ్ట్ యాక్షన్స్ ఆర్ సేమ్, ఓన్లీ రెడ్యూస్ యాక్షన్స్ ఆర్ డిఫరెంట్. రెడ్యూస్ అనేది ఓన్లీ వెన్ ఎవర్ ఏ ఫైనల్ ఐటమ్ ఇస్ దేర్ ఇన్ ద స్టేట్, ఆ పర్టికులర్ రిడక్షన్ అనేది ఎక్కడ పెడతామంటే ఓన్లీ ఆన్ ద ఫాలో ఆఫ్ దట్ సింబల్. ఫాలో ఆఫ్ ఎస్ లో ఏవైతే సింబల్స్ వస్తాయో ఆ సింబల్స్ లో మాత్రమే రిడక్షన్ పెడతాం. So find out what is the follow of S here. For example, I want to write only for this one. This is I7, right? Okay. So ఇక్కడ I7 ఉంది. So I7 లో ఎక్కడ రిడక్షన్ ఆపరేషన్స్ పెట్టాలి? So first find out follow of S. Follow of S అంటే ఎలా కనుక్కుంటున్నాం? Only see the left side, right side where S is there. S ఎక్కడా లేదు కదా? ఎక్కడా లేదంటే ఓన్లీ డాలర్. Consider why? Because S is a starting symbol, so S is follow of S contain $. So only on $, yes, 7 on $, reduction operation. Only 7 on $, you can write the reduction with production 3 or just write in that terminal only. So that is nothing but SLR of 1 table.